All right, today we're going to be talking about making sense about division involving zero. In particular, we'll be dealing with problems such as 0 divided by, say, 6, 24 divided by 0, and 0 divided by 0. And these will typically be written in your calculus course as fractions, 24 over 0 and 0 over 0, and so on. Little side note here, you might want to consider why is it that the division problem and the fraction number there are the very same thing. It might be a little bit more complex than you think to show that, but we're not going to do that today. We're going to be looking at, though, these problems, and in particular, the 0 over 0 at the very, which we'll be doing at the very end, will involve what you'll be working with in a big way here in calculus, because that's going to be the definition of every derivative that you take. And so it's a good idea to get a good hold there of what 0 divided by 0 or 0 over 0 is. So let's begin here with our base problem here, something like 24 divided by 6, to kind of get a handle on what division is and what can be solved with division here. And so let's look at this problem. We have 24 miles to go on a journey. Assume we can only drive at a constant rate of 6 miles per hour. How long will it take to complete the journey? And you're probably thinking, well, duh, that's an easy answer. That's 4 hours there that it would take. Multiplication-wise, we're going to look at this as, well, we want to go 24 miles here. How many hours at 6 miles per hour times 6 miles per hour will give us those 24 miles here? And obviously the answer is 4 hours here. Another way you might want to think about this here is look at your 24 miles and start taking away 6 miles for every hour here. So 6 miles and out, 6 miles for this hour, 6 miles for this hour, 6 miles for this hour, 6 miles for this hour here. And finally we're left with 0 miles, which means here it took 4 of those hours to go to cover the 24 miles. Another way to look at division that we'll be working with here will be to switch what the 6 means here. In this case, we have 24 miles to go on a journey again here, but now we're setting what our time has to be. We want to get there in precisely 6 hours here. And now we're asking at what speed should we set our cruise control to achieve the goal. Cruise control meaning we're going to be going at a constant rate for the entire journey. And once again, we have 24 miles. And this time here, we know how many hours there are, so this is going to be 6 hours. We want to know here what fills in here in terms of our rate, in terms of miles for every hour here that we need to go to make the 24 miles in exactly 6 hours. And once again, the numerical answer is 4, although this time 4 is representing the rate of 4 miles per hour. Looking at it another way here, let's split up our 6 hours like containers here. And we want to know here how many miles we need to put in each one of these hours here. So this is 1 hour, and we have 24 miles there, and we could split this up like pieces of candy. And so we could take 1 mile, put in each one of these here. We've covered 6 miles now, and now we want to, or 6 hours I should say, and now we still have 18 miles still to fill, and so we put each of those miles into another hour. And now we have 12 miles still to go here, and we have 2 miles in each one of those hours, and we can continue doing this obviously here and get 4 miles in each one of the hours here. This is equivalent to the old division question. You have 24 pieces of candy and 6 kids, and they want to share them equally. They want to be on cruise control here. So how many pieces of candy per kid? And so that would be 4 pieces of candy here, except this isn't as delicious here on our journey. Well, now we want to go and consider our problem of 24 divided by 0 and 0 divided by 6 and 0 divided by 0. Let's look at 0 divided by 6 first here. So now we're looking at a story problem for 0 divided by 6. We have 0 miles to go on a journey. Assume that we can only drive at a constant rate of 6 miles per hour. No other speed will do. How long will it take to complete the journey here? Well, now our 0 here is replacing where the 24 used to be on our story problem before, but you'll notice here that this is exactly the same problem we had before, except that that 24 is now changed to a 0. And so now we have 0 miles to go. And just like our first division problem that we had, we know what our constant rate is, 6 miles per hour. And we want to fill in here what number we'll fill in to multiply by 6 miles per hour to give us the 0 miles here. And obviously, the answer is 0 hours here. Any other time, we would be going some other distance other than 0 miles, since we're going at 6 miles per hour. So we better stay put and spend 0 hours there going the 6 miles per hour. And that makes sense. In looking the other way here, such as the candy problem, we have 0 miles to go on a journey. We want to get there now in precisely 6 hours. So now we still have the same amount of time we want to spend, 6 hours, but this time we want to go 0 miles. At what speed should we set our cruise control at to achieve the goal? Because we want to, again, go at a constant speed. And once again, we have 0 miles here. This time we know the 6 hours. And we want to know there at how many miles per hour should we go to accomplish the 0 miles. So we want to spend 6 hours of our time there, but we better not go at any speed here if we want to go at 0 miles per hour. So we're basically going to sit in our garage for 6 hours here and go at 0 miles per hour to solve the problem. The big story here is that no matter how you look at this, no matter which version of division that you're looking at here, the only numerical answer that makes any sense for 0 divided by 6 or any non-zero number is 0. Now we're going to go on here and talk about 24 divided by 0. So we're going to be switching the role of where 0 is here and keep the 24 where we had it. This is going to be a little bit more tricky. We are going to first look at it from a multiplication point of view, but then look at it again as somewhat of a repeated subtraction or a handing out situation like we did before in our base problem of 24 divided by 6. So here we have 24 miles to go on a journey. Assume that we can only drive at a constant rate of, and I'm going to write there, x miles per hour. This will eventually be 0 miles per hour by the time we're done. How long will it take to complete the journey? And I'm going to take different values of x here, and we're going to look at it that way and see what makes sense. First of all, though, if we look at it purely from a missing factor problem with multiplication, again, we're looking at 24 miles total that we want to go here. And we're given our speed of, in this case, we want 0 miles per hour here. And we want to know how many hours it will take to go the 24 miles. Well, as we know, there are no numbers here that can actually fill the bill. There's no numbers that we know that can fit the bill here, because any number, any real number that we have multiplied by 0 gives us 24 miles. And so this is why many times in school you would say, well, 24 divided by 0 is undefined, because no real number can solve that problem. However, as we'll see, this undefined word actually could mean a couple of different things here. And in the 24 divided by 0 case, we're going to be talking about a specific kind of undefined. And this undefined is somewhat like the same undefined we had back in, say, middle school when we were talking about integers here, when we said 4 minus 7, and all we were doing was allowing ourselves to work with whole numbers that didn't have an answer in that system. We're going to find that 24 divided by 0 somewhat has an answer and if we extend our system of real numbers here to go beyond real numbers to things that really aren't numbers. I know that kind of sounds strange, but we'll see what happens in a few minutes here. What we're going to do here is take kind of a limit approach, somewhat of the same approach that you'll do in the pre-calculus portion of 1151. And we're going to take the problem here and go, instead of saying we have 24 miles to go on a journey, assume we can only drive at a constant rate of, first of all, we're going to say 6 miles per hour, and then we're going to answer the question. And then we're going to do the same thing for 1 mile an hour, 1/100th mile an hour, and so on, and see what seems to be happening there as we work our way going slower and slower and slower to achieve the goal of going 24 miles. And so our first question here is 24 divided by 6. And we solved this earlier here. We have 24 miles to go at 6 miles per hour. We want to figure out how many hours it would take to go the 24 miles. Once again, we could take that 24 miles and keep subtracting 6 over and over and over again until the 24 miles has been taken up. We have 0 miles still to go, and the answer would be 4 hours. But what would happen now, instead of at 6 miles per hour, we now go at 1 mile per hour. Now we're going to be taking that 24, and it's going to take a bunch of different subtractions there because every hour is only going to be taking 1 mile away from our journey here. And so it's going to take a long time. It's in fact going to take 24 hours there to work our way to 0 miles there. So we have there the 24 divided by 1 would be 24, in this case 24 hours to take that journey. What about 1/100th mile per hour? Same deal. We have 24 miles to fill, and it's going to take a whale of a lot of time there to fill it, going at the snail-like speed of 1/100th miles per hour here. In fact, to work our way to 0 miles here, it would take 2,400 hours to make the journey. But it's still possible if we were patient and brought a lot of food and so on to work with. What about if we were going 1/1,000,000th mile per hour? Well, in the same sense here, and I won't write out the subtraction here, but we can say it's going to take very, very much longer to go the 24 miles. It's going to take 24 million hours to complete the journey. So the idea here is what's happening to these numbers. As we decrease our speed, it's going to take us a lot longer to go the 24 miles. The ultimate question, of course, is what about 0 miles per hour here? Well, we could keep subtracting till the cows come home, and we're never going to achieve our 24 miles. In fact, again, we won't even get out of the garage at 0 miles per hour. However, we have an idea here that whatever that number might be, it's going to be a very, very large number here. So 24 divided by 0 here is very large. And in fact, we don't really know a number, again, that fits this box here from before. But what we do know here, that if it's anything here, and if we extend our system here, we can get an idea here that this would be somewhat equal to what we might call infinity. And infinity is not a number, but it is somewhat of a concept there, in that no real number fits this box here. But if we're going to go at the slowest of slowest speeds there, to get our 24 miles, we're going to have to go the the largest number of hours to get there. And the largest number you might be able to think of there isn't really a number, but it's somewhat infinity here. Let's look at this in another way with the other version of division. This time we again have 24 miles to go on our journey. We want to get there in precisely x hours. And again, we're going to have several values of x. And at what speed should we set our cruise control to achieve the goal? And once again, our old problem there was we had 24 miles. And we wanted to take 6 hours to get there. Obviously, 4 miles an hour was the speed that we wanted to go. Okay. What if we changed this here? We wanted to get there in a much shorter amount of time, into 1 hour here. Well, it would take us a lot faster to get there. We would have to go take that whole hour there and spend the entire 24 miles in that 1 hour. So it will be 24 miles in 1 hour that would fit this here. In the container situation, if you remember, we had 6 containers in our previous problem here. Here we basically only have 1 container here. And it's basically asking here how many miles should go into that 1 container at that for that 1 hour here. So what will fill up the 24 miles there in that 24 miles will fill up 1 container here. That means we have to go 24 miles in that 1 hour. What if we wanted to go 1/100th of an hour for our journey? We're going to have to go very, very fast to go 24 miles. One way to think of it with the container here is that the 24 miles now fills up. This is not to any scale whatsoever here, but 24 miles here basically fills up 1/100th of our container of 1 hour here. So this is 1/100th of an hour here. We want to know how much will fill up 1 hour here. In other words, we want to know how many miles we're going to go in 1 hour. We know that 24 miles fills up 1/100th of an hour. So it will take here 100 copies of that 24 miles to go for 1 hour there. So it would take here 24 here essentially divided by 1/100th. Here's a little bit of a justification for flip and multiply here. This would be 24 times 100, which will be 2400 miles per hour there. So we will have to break the speed limit slightly there to get us there in 1/100th of an hour. In the same sense, for 1/1,000,000th of an hour, we want to get there. We're going to have to go 24 million miles every hour that goes by here. That might be slightly impossible on the Earth, but who knows? But that's what the mathematics tells us to do here. And once again, what we're seeing though is that if the amount of time goes down that you want to cover the 24 miles in there, you have to go at a faster and faster and faster speed. And if you want to get there in no time at all there, you're going to have to go faster basically than warp speed then to go the 24 miles. And in fact, as we saw before, there is no real number that fits into that box there. And if it's going to be anything here, it's going to be a very, very, very large number here, at least going by the pattern that we've adjusted. So once again, we see that 24 divided by 0 here is essentially not technically undefined here, but let's just call it very, very big, whereas before we saw 0 divided by 6, or 0 divided by any non-zero number there, is equal to 0, which I would consider very, very small. Now, I've taken a few liberties in talking about this here, and in fact, even the equal sign here at least with the infinity situation, is not really an equal sign, okay, in terms of anything. It's because it's not a number whatsoever here, but what we do know that if it's anything here, it's very, very big. Now, a little bit later, and perhaps in a previous course, you looked at this in a function situation here when you were looking at y is equal to 24 divided by x, or over x here, and you're looking at the graph of this as x got very, 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 very small on the x-axis here toward 0. And of course, what you saw there was you had a vertical asymptote. It never really hit x equal to 0 there because there was no number there that would work as we've described. But what it does do is it gets very, very, very large as our x gets closer and closer to 0. So in that sense there, it is somewhat undefined, at least if we extend our system. It's somewhat defined actually here if we extend our system to include infinity in our family of quasi-numbers. Now let's look at 0 divided by 0. And once again, this is probably going to be the most important to you in studying calculus because this limit, or I should say this calculation of 0 over 0, will essentially occur in every time that you take a derivative. And differential calculus is basically the heart and soul of the, I would say, 2/3, maybe 3/4, maybe more of Math 1151. And so it's a good idea here to get a good feel for what's going on when we have 0 divided by 0. Now on one hand, before we get to the story problem, we actually have a different sort of undefined going on here. Just looking at it from one point of view is we've talked about 0 divided by 6, or 0 divided by any non-zero number to be 0, or very, very small. And we've talked about 24 divided by 0 as being very big, or we could sneak in an infinity. Now, which one do we pick here? Because with 0 divided by 0, we've got both things going on here. We have 0 here, and we have 0 here. And on one hand, we look at it as very, very small, but on the other hand, we look at it as very, very big. So we seem to have a big contradiction going on here that wasn't occurring in our first two issues. So what do? Well, let's look at the story problem here, although it might seem a little crazy. Now I've changed both numbers. Where the 24 was, there's a 0, and where the 6 was, there's a 0 here. We have 0 miles to go on a journey. Assume we can only drive at a constant rate of 0 miles per hour. How long will it take to complete the journey? Well, if we look at it from a multiplication point of view, here we have 0 miles taking the place of the 24, and we have 6 miles an hour. Now we have 0 miles an hour taking the place of the old 6, and we want to know how many hours it will take at that rate to go 0 miles. And the only answer, or actually any answer really, fits the bill here because you're going at a 0 speed here. You're sitting there in the garage, haven't even started the engine yet, and you're going at 0 miles per hour. And so you can sit there all day if you want and still go 0 miles for the journey. Therefore, really, any number that we want can fit into that multiplication. And so, for example, 7.5 would work, pi would work, square root of 2 would work, you name it here. Any number can fit that problem. Even -5 can work here if you want to talk about time ago rather than time forward here. So we have a different kind of undefined here than we had before. With 24 divided by 0, that only seemed to go with big. And infinity here, no real number really fit the bill. But with 0 divided by 0, anything can fit the bill. So really we have somewhat not of a kind of a set place that it has to go here, but really any number, any place can work for this problem. This is somewhat like when you had order of operations invented in elementary school, when you said 5 plus 2 times 7 could be defined, and you can make up story problems that would make sense here. This would be 7 times 7, or 49, some people might say, or they might say 14 plus 5 and get us 19. Either number makes sense there within the story problem context. We happen to pick the one where we're doing the multiplication first, more as a social convention than any mathematical one, so that we're all on the same page. This is an undefined by ambiguity, because we have more than one number that fits the bill, that solves the problem here. Later ones here, as you'll be calling these indeterminate forms, which means we don't know the answer just looking at it right off the bat, will be, for example, 0 to the 0. We have 0 to a number, that's usually 0, but yet we have a number to 0, that's usually 1. Which do you pick? Who knows? It could be anything. Other things involving that would be, say, infinity minus infinity will also be what we call an indeterminate form. We have a big number and we subtract a big number, but who knows where in the realm that we land after doing so. Let's see if that same thing happens, that ambiguity or indeterminate situation happens in the other way of looking at division. We have 0 miles to go on the journey again, same old thing. We want to get there in precisely 0 hours now. At what speed should we set our cruise control to achieve the goal? So again, we have 0 miles to go. And this time, we're given the amount of time, 0 hours. And we want to know what to set the cruise control at. What speed should we go for 0 miles to go? Total of 0 miles total. And so, we could really set it at any speed we want. So all we have to do is set the button, say, at 5,000 miles per hour, if we could do that. And just do that for 0 hours here, and of course we will go 0 miles. We could set it at -8 miles per hour. Say go westward instead of forward here, 0 miles. And once again, you don't even start the car. You do that for 0 hours, you're going to go 0 miles. So once again, basically any number can fit the bill to solve that problem, because you're not taking any time for your journey and you're not going any distance. So you can pretend to go any speed you want for that time. So once again, any number works. So in the case when you see 0 over 0 going on, later on when you deal with derivatives, and you'll be doing this within, again, a limit situation like we talked about with 24 divided by 0, you're going to have to get a lot more further information to determine which number is going to work for your particular situation. So therefore, what we have here is that 0 divided by a non-zero number is going to be 0, making sense from the stories. We have a non-zero number divided by 0 will tend to be very, very big. And we have to be very careful here. I should have mentioned before, this big could also be a very negative big. In what we talked about, there were positive number situations there. So that's why we were always getting positive speeds or positive times. But in our case here, we might also get a negative number here later on. So be very, very careful here. So this actually could be a plus or minus big, depending on what's happening here. And then finally, 0 divided by 0 is an indeterminate undefined. So you have no idea what that number is until you do further work with it.